Hello and welcome to the next lesson in this free Hyper-V training course for Windows Server 2012 and Windows Server 2012 R2. In the last lesson, I demonstrated how to create a Generation 1 virtual machine in Hyper-V. Now that the virtual machine has been created, the next task is to install an operating system onto that virtual machine. Until an operating system is installed, there is not an awful lot you can do with the virtual machine. Therefore, in this lesson, I will discuss and demonstrate the options available for installing an operating system onto a Hyper-V virtual machine. Before we get started, it pays to know exactly what methods of installation are available to us. In this lesson, I will look at 3 ways to install an operating system onto a Hyper-V virtual machine. This will include using the traditional Windows DVD, using an ISO image, and finally, performing an installation over the network. Let's start by looking at installing Windows using the DVD. For many years, the most common and arguably the most popular method of installing Windows is by using the Windows DVD. With this approach, you would simply purchase a copy of Windows from a retailer. When you purchase Windows in this way, you are purchasing a DVD which contains the Windows operating system. Installing the operating system is simply a matter of inserting the DVD into the computer and booting off it. Keeping to this tradition, virtual machines in Hyper-V also permit you to install an operating system using the DVD. To do this, you simply need to insert the Windows DVD into the Hyper-V host. Then, in the settings for your virtual machine, you can instruct the virtual machine to boot from the Hyper-V host server's DVD drive. To demonstrate how this works, I will now change over to my Windows Server 2012 R2 Hyper-V server. First, you need to insert the Windows operating system DVD into the optical drive of the Hyper-V server. If I open File Explorer, you can see that I have already inserted my Windows DVD into my E drive. I will now close File Explorer and return to my desktop. From the desktop of your Hyper-V server, open Server Manager from the bottom left corner and select Tools from the top right corner. From the drop-down list, select Hyper-V Manager. This will open the Hyper-V Manager console. From here, you can see the virtual machine I created in the last lesson, vServer1, listed. To prove that this virtual machine does not have an operating system installed, I will double-click it to launch the virtual machine console and will then click the green Start button. The virtual machine will start to load up. Notice, however, that the virtual machine is reporting a boot failure and is prompting me to reboot and select a bootable device. This is because it has failed to locate an operating system. I will now turn off the virtual machine and will return to Hyper-V Manager. To install Windows from the DVD, I need to instruct my vServer1 virtual machine to boot from the DVD drive on this Hyper-V host. To do this, right-click on the virtual machine and select Settings from the drop-down list. This opens the settings for my vServer1 virtual machine. Generation 1 virtual machines primarily use IDE controllers as their main storage subsystem. When you create a Generation 1 virtual machine, 2 IDE controllers are automatically created for you. These are named IDE Controller 0 and IDE Controller 1. These are essentially virtual equivalents of regular IDE controllers found in physical computers. Just like regular IDE controllers, you can attach a maximum of 2 devices to each IDE controller. That is, 2 devices can be attached to IDE controller 0, and a further 2 devices can be attached to IDE controller 1. It is worth noting at this point that the IDE controllers cannot be removed from the virtual machine, nor can you attach additional IDE controllers. If I select IDE controller 0, notice that Hyper-V will allow me to attach 2 types of devices. These are virtual hard disks and virtual DVD drives. If you look beneath the IDE controllers, you can see which devices are currently attached to the controllers. When you create a new virtual machine in Hyper-V, if you make the decision to create a new virtual hard disk at the same time, Hyper-V will attach this virtual hard disk to IDE controller 0. As you can see, the virtual hard disk I created for my vServer 1 virtual machine in the last lesson, named vServer1.vhdx, has been attached to this IDE controller. Also, when you create a new virtual machine, Hyper-V automatically attaches a virtual DVD drive to IDE controller 1. The virtual DVD drive is required to point the virtual machine to some kind of installation media. If I click on the virtual DVD drive, notice that I have the option to point this virtual drive to a physical CD/DVD drive on the Hyper-V host. Since I want to install Windows onto this virtual machine using the Windows DVD, I will point this to my E drive, which contains my Windows installation media. I will accept these changes by clicking the OK button. My vServer 1 virtual machine is now able to detect and boot to the Windows DVD currently sat in the E drive of my Hyper-V host. If I start the virtual machine back up again, notice that this time the virtual machine will boot to the Windows DVD. I can then install the operating system onto this virtual machine just as if it were a regular physical computer. The next way to install an operating system onto a virtual machine is to use an ISO image. When you purchase a copy of Windows directly from Microsoft as a download, it will often be provided as an ISO file. After downloading the ISO file, it is then traditionally burned to a blank DVD, allowing you to create physical bootable media. However, with Hyper-V, this is not necessary. Hyper-V is able to read ISO files directly, saving you the task of having to burn them to a DVD first. To install Windows onto a virtual machine using an ISO file, all you have to do is point the virtual DVD drive to the ISO file, rather than to a physical CD or DVD drive on the Hyper-V host. To demonstrate this, I will now change back to my Windows Server 2012 R2 Hyper-V server. If I open File Explorer, notice that I have now removed the Windows DVD from the optical drive of this server. Furthermore, if I open the D drive of this server, you will notice that I have an ISO file. This is the 180-day evaluation version of Windows Server 2012 R2 which I have downloaded from the Microsoft website. This is the file that I will point the virtual DVD drive to from my vServer 1 virtual machine. I will now close File Explorer and, using Server Manager, I will reopen the Hyper-V Manager console. Next, I will open the settings for my vServer 1 virtual machine. From IDE Controller 1, I will select the virtual DVD drive. Notice that I can choose to point this virtual DVD drive to an image file. With this option selected, I will then click the Browse button and will navigate to the ISO file I showed you earlier in my D drive. With the ISO file selected, I will accept the changes by clicking the OK button. My vServer 1 virtual machine is now able to detect and read the ISO file from the D drive of my Hyper-V host server. If I start the virtual machine, the ISO file will start to boot. Once booted, I can then install an operating system onto the virtual machine in much the same way as using the Windows DVD. The final method of installation that I would like to demonstrate is a network-based installation of Windows. This method of installation is likely to be used in highly virtualized environments such as data centers. A network-based installation allows you to install the Windows operating system onto a virtual machine over the network. In order to use a network-based installation, your network will require some kind of a deployment server. With Windows Server 2012 and Windows Server 2012 R2, Microsoft allows you to create a deployment server by installing the Windows Deployment Services role. When a Windows server has the Windows Deployment Services role installed, you can easily store a copy of the operating systems you want to deploy on that server. Operating systems stored on a Windows Deployment Services server are called images. These images can then be rolled out and installed onto virtual machines over the network. One of the advantages to using a network-based installation system such as Windows Deployment Services is that it supports multicasting. Multicasting allows the same packet of data to be sent to multiple virtual machines at the same time. To put it another way, let's say you have a Hyper-V host with 3 virtual machines. You want to install Windows Server 2012 R2 onto all 3 of these virtual machines. Elsewhere on the network, you have a Windows Deployment Services server that contains a Windows Server 2012 R2 image. If you were to start the installation of Windows on all 3 virtual machines at the same time, there is a high probability that the virtual machines will end up requesting the same installation files at the same time. Windows Deployment Services, however, is intelligent enough to send 3 separate copies of the same files to all 3 virtual machines. This stops the virtual machines from queuing to access the installation files and helps to speed up the installation. To perform a network-based installation, your virtual machine will require network connectivity so that it can contact a Windows Deployment Services server. This is done by creating a virtual switch. Virtual switches are created from the physical network interface cards installed in the Hyper-V host. When you create a virtual switch, you will have to choose which of the network interface cards from the Hyper-V host you'd like to turn into a virtual switch. Once the virtual switch has been created, you can attach it to the virtual machine. The virtual machine will see the virtual switch as a locally installed network adapter. This puts the virtual machine onto the network and will allow it to communicate with the Windows Deployment Services server. To demonstrate this better, I will now change back to my Windows Server 2012 R2 server. First, I will open Network Connections so that I can see the physical network adapters that are installed in this Hyper-V host. As you can see, there are 3 network interface cards installed in this host. These are Ethernet, Ethernet 2, and Hyper-1 LAN. When I create the virtual switch for my vServer 1 virtual machine, I will be asked to select one of these network adapters to turn into a virtual switch. Since the Hyper-1 LAN network adapter is the adapter connecting my Hyper-V host server to the network, and since I am a fan of allocating each virtual machine its own dedicated network adapter, I will use the Ethernet and Ethernet 2 network adapters to create virtual switches. I will now close Network Connections and will open Server Manager, followed by Hyper-V Manager. To create a virtual switch, from the right side of the console, select Virtual Switch Manager. This opens the Virtual Switch Manager dialog box. From the left pane, select New Virtual Network Switch. To the right, you are able to select which type of virtual switch you'd like to create. There are 3 types of virtual switch to choose from. The default, and most commonly used, is an external virtual switch. An external virtual switch allows every virtual machine using this virtual switch to communicate with the other computers on the network. The next type is an internal virtual switch. An internal virtual switch allows every virtual machine with this virtual switch to communicate with each other and with the Hyper-V host, but not with the rest of the computers on the network. The last type is a private virtual switch. A private virtual switch allows every virtual machine with this virtual switch to communicate with each other, but not with the Hyper-V host or any of the other computers on the network. Don't worry if you are a little confused about the virtual switch types. I will dedicate an entire lesson to virtual switch creation later on in the course. What's important for you to understand right now is that I need my vServer 1 virtual machine to be able to communicate with my Windows Deployment Services server so that I can download and install an operating system. The only virtual switch which is capable of doing this is the external virtual switch type. So I will select this by clicking the Create Virtual Switch button. This will open the Virtual Switch Properties screen. First, I have to choose a name for the virtual switch. By default, Windows will suggest the name New Virtual Switch. So I will change this to vServer1_NIC to make it easy to identify. Next, I can add some notes to this virtual switch if I wanted to. Further down, in the connection type settings, I will once again choose to create an external network virtual switch. From the drop-down list, I can select which network interface card from the Hyper-V host I'd like to use to create the virtual switch. In my case, I will select Realtek PCIe Gigabit Controller 3, since I already know that this is my Ethernet network adapter. When the adapter is selected, click the OK button. Notice at this point that I will receive a warning message stating that creating the virtual switch may temporarily disrupt network connectivity. To proceed with creating the virtual switch, click the Yes button. Hyper-V will apply the changes and will create the virtual switch. Now that the virtual switch has been created, the next step is to attach it to the vServer 1 virtual machine. To do this, first open the settings for the virtual machine. If you look at the devices listed in the settings, you will see a device named Network Adapter. As you can see, this is currently reporting a status of not connected. In the main pane, you will notice a virtual switch drop-down. From here, I am able to select my vServer1_NIC virtual switch and attach it to the virtual machine. However, if I were to do this and start the virtual machine, the operating system installation will not work. This is because the default network adapters in Hyper-V do not support PXE booting, which is a requirement for network-based installations. To get around this, you have to add a special type of network adapter which does support Pixie booting. To do this, click the Add Hardware setting. From the list of hardware on the right-hand side, select Legacy Network Adapter and then click the Add button. Notice that the Legacy Network Adapter has appeared in the list of settings. With the Legacy Network Adapter selected, I can choose to assign it my vserver1_NIC virtual switch. To make the changes, I will then click the OK button. My vserver1 virtual machine is now capable of performing a Pixie boot and installing an operating system over the network. One final point I would like to make is although legacy network adapters do support network-based installations, they are acknowledged by Microsoft as being slower than the regular Hyper-V network adapters. For that reason, once the operating system has been installed, I would remove the legacy network adapter from the virtual machine altogether. I would then attach the virtual switch to the regular network adapter to ensure you get the best performance. If I start my vserver1 virtual machine, notice that I am given the option to perform a network service boot. This will essentially download the Windows operating system from the Windows Deployment Services server so that it can be installed onto the virtual machine. This concludes this lesson on how to install operating systems onto virtual machines in Hyper-V. I hope this lesson has been of some use to you. In the next lesson, now that the operating system is installed, I will look at guest integration services. For more Windows Server 2012 and Windows Server 2012 R2 training videos, check out our collection of YouTube videos. And remember to show your support by liking our videos and by subscribing to our channel. Many thanks, and we'll see you on the next lesson.